position. Okay, understood. Please check it. Please check it and tell me, is it clear? Hello.
Yes, sir. Clear.
Right. So work done by spring is going to be minus half kx square, where x is what? Elongation or compression. So when spring is being elongated or compressed from natural position, what will happen? The work done by the spring it will be negative. And when it will be positive, the work done by spring it will be plus half kx squared. And when the work done will be positive, when spring is already in the elongated position or already in the compressed position, and now it is brought back to where? Brought back to the natural position. Understood? So in that case, work done by spring will be what? Positive. Okay. So when the work done by spring is positive, when spring is brought back to natural position. Okay, brought back to natural position from where? From elongated or compressed state. Understood? From both state, whether the spring was initially elongated and now it is brought back to the natural position, the work done by spring will be positive. And if the spring is already compressed and now compressed by how much? This x is what? This x is the elongation or compression. Understood? Clear? So this is the work done by gravity and work done by spring. And please keep in mind one more thing, that gravity and spring force, these two forces are conservative in nature. So work done by these two forces will be what? It will be independent of the path. Independent of what? Path. Means what? Work done by gravity is always going to be mgh. Instead of or irrespective of how the particle went from initial to final point. The work done by gravity only depends on what? mgh, where h is the height difference between the 2 points. Is that clear? Where h is what? H is the height difference between the 2 points. Is that clear? And if again, if the particle is taken up, the work done by gravity is going to be negative. If particle is taken down, the work done by gravity is going to be positive. Understood? So these two, spring force and gravity. Okay, now spring force and gravity force, okay, are conservative in nature. What kind of these two forces are there? Are conservative in nature. So work done by these two forces, okay, work done by these two forces, these two forces are independent of path, are independent of path, okay. But other forces which is non-conservative, their work done will depend on path, like friction, tension, normal. These are non-conservative forces, okay. So these forces work done will depend on the path. That means what? That the work done by non-conservative force depends on force, displacement, and as well as how the particle moved from one point to another point. It depends on that factor also, okay. But gravity and spring force are conservative in nature, so these two forces work done will remain independent of the path. Is that clear? So this is about the work done by two of the common forces, gravity and spring. Okay. Now we have to relate the this work, and there will be other forces work done also. We need to calculate it: external force work done, uh, friction work done, tension work done, normal work done. Okay, na? So these forces work done, we will see it as it will come in the question. Everywhere to calculate the work done, we have to apply the definition of the work done. And what is that? The work done is the dot product of force and displacement. Understood? Now, how do we apply these work done concept? That is applied in work energy theorem. Okay, so to understand the work energy theorem, let's first try to understand what are the different type of energy. Type of energy means what kind of energy we are discussing here? Type of mechanical energy. The energy we are talking here, we are going to call it as the mechanical energy, not the heat energy. Okay, heat energy, internal energy, mechanical energy. Okay, so mechanical energy, we have an object can have two type of mechanical energy. What are those? The first one is the kinetic energy. What is the kinetic energy? It is the energy a particle is having because of what? Because of its velocity. If a particle is having some velocity, what will happen? It will have some kinetic energy. And the second type of mechanical energy a particle can have is going to be what? The potential energy. So let's try to learn about these two form of energy. How do we calculate the kinetic energy and how do we calculate the potential energy? Okay. So let's first try to learn about the kinetic energy. So what is the kinetic energy a particle has? So kinetic energy a particle has, it is due to the velocity of the particle or due to the motion of the particle. If a particle is in the motion, it will have what? The kinetic energy. And keep in mind, we are discussing about what kind of motion? Translational motion, not the rotational motion. In the translational motion, the kind of energy a particle is going to have will be called as the translational kinetic energy. Understood? So, what is that kinetic energy? It is the energy. It is the energy due to what? Due to motion. Clear? What is the kinetic energy? It is the energy due to the motion. Understood? So what is the kinetic energy mathematical formula? Kinetic energy, how much kinetic energy a particle will have? The kinetic energy is half mv square, where v is what? It is the magnitude of velocity of the particle. Okay, kinetic energy k, we can write it as half m v square. What is the v here? V is the magnitude of the velocity a particle has. It can be also written in some different form. What is the different form? See that mv square we have na, can be multiply 1m and can be divide 1m. And if you write it like this, you see that what is this written? M square v square. Is it the momentum written? So p square by 2m. So if you want to write the kinetic energy, what you can write about the kinetic energy? Kinetic energy can be written as half mv square, or it can be also written as what? P square by 2m, where p is what? P is the momentum of the particle. Okay, so momentum and kinetic energy, there is a relation, isn't it? Can you write it? Momentum is going to be under root of 2m into kinetic energy. Please keep in mind, p is the momentum here. P is what? Mass into velocity, which we call it momentum, or you can also call it as the linear momentum. Clear? So kinetic energy a particle have is called half mv square, which is also called as p square by 2m, where p is the momentum, not the power. In this chapter, power will also come, but here p we are representing for what? The momentum. Understood? So if you are changing the kinetic energy of a particle, actually you are changing the momentum of the particle as well, isn't it? If you change the kinetic energy of a particle, its momentum will also change. Why? Because kinetic energy and momentum of a particle are related with each other. Is that clear? Now, once we know the kinetic energy, there is a very important, or you can say that most important theorem of this chapter, okay, called what? Work energy theorem. Okay, let's first learn about the work energy theorem. Okay, after that, we will learn about the potential energy. Now, we will learn about the work energy theorem, and we will practice some questions on the work energy theorem. So, what is work energy theorem? What is the purpose of doing the work on a particle? Please tell me, what is the purpose of doing the work on a particle? Please tell me, what is the purpose of the work done? The simple purpose of the work done is what? To change the kinetic energy, isn't it? Whenever we will do the work done, what will happen? The kinetic energy is going to change, isn't it? And if kinetic energy is going to change, then what is the relation between the kinetic energy and work done? So that is given by what? The work energy theorem. Is that clear? So, as per the work energy theorem, change in kinetic energy, please keep in mind, this is a very important one because this is going to use many places, not only the work energy chapter, but it is used in electrostatics also. Seen it many times, we have used in the electrostatic. So, change in kinetic energy is equal to work done, work done by all the forces. Clear? Work done by what? All the forces. So change in kinetic energy of a particle is what? It is equal to work done by all the forces acting on the particle. Clear? In the symbolic form, what you can write it? K final minus K initial equal to what? Work done by all. What does it mean by work done by all? Can we also write this expression like this? Half mv final square minus half m v initial square. Is that the change in kinetic energy written? And work done by all the forces means what? Work done by many different forces are there. What are those forces? Normal is there, tension is there, gravity is there, isn't it? Spring force is there, friction is there, uh, buoyancy force is there, some external force is there, isn't it? So whatever these forces are there, okay na, gravity is there, spring force is there. Next, what kind of other forces will come? The friction will come. Next, what else will be there? Some external forces are acting on the body. So if we are able to write down the work done by all these forces, and if we add them, then what are we going to get it after adding all these work done? So after adding all these work done, we are going to get the change in kinetic energy of the particle. Is that clear? Please tell me, understood this one? Now let's practice some questions on this, how to calculate the kinetic energy, and another thing, what is the how to apply this work energy theorem. Understood? Please tell me, clear up to this what we have discussed?
Yes,
Please
sir.
tell me, clear up to this what we discussed? Right. Now let's start with some example now. Okay. In this example, what is given to us? That a curve track is given to us, and this curve track now it becomes horizontal once it reaches this, uh, and a particle of some 5 kg is sliding from this height. Okay, this straight segment is there na? The height of this straight segment is given to us. That height of this straight segment is given to us as 5. meter given to us. Okay, up to the horizontal section where it is not starting, this part of the track is what? Smooth. Okay, this curve path is what? It's a smooth, and this horizontal part is what? It's a rough, and this rough part has a coefficient of friction mu equal to 0.4. Okay, 0.4 is given to us. So now they are asking in the question, find a distance traveled by the particle. Okay, find distance traveled traveled by the particle or body to come to rest to come to rest on the horizontal region or horizontal part. Okay, now clear? The curve part is what? Smooth, and there is only roughness in which part? In this horizontal part. Okay, and initially it is starting from rest. We did not push it. Okay, this block is not pushed. It is starting. It is released from this curve part. Okay, so how much distance it will travel on this rough surface before it will come to rest? Okay, apply the work energy theorem between the initial point and the final point, and tell me what is that distance traveled by the particle on the horizontal part when it comes to rest. Okay, so please tell me how much is that coming. Tell me how much is that coming. What is the distance traveled by the particle before coming to rest? Before coming to rest means what? Again, the final kinetic energy will become zero, isn't it? So that means your initial kinetic energy is zero, your final kinetic energy is zero, isn't it? So you got the final kinetic energy and initial kinetic energy. Now you have to apply, or you have to write the work done by all the forces you see it in the diagram. Okay, what are the forces you see it in the diagram? Please tell me. What are the forces you see it in the diagram? Can you tell me? Tell me, what are the forces we see it in the diagram when the particle goes from its initial point? Let's call the initial point as something A. Okay. And finally, it comes to rest. Comes to rest means final velocity also zero. Let's call it B. So when the particle goes from A to B, there are actually three forces acting on that. A to B throughout mg is acting. A to B throughout normal is acting. But friction is only acting from where to where? From, let's call it, C to B. So let's write it work energy theorem. If I am writing work energy theorem, I will write it work done by normal, work done by gravity, work done by friction. And friction is going to be kinetic in nature. Now, finally, the particle comes to rest. Final kinetic energy zero. Initial particle is starting from rest, so initial kinetic energy zero. Now, if you look at the diagram, you will see normal work done is zero. right or not? Because if you look at the particle here, normal will be acting like this, displacement along the tangent. So you see that normal and displacement, isn't it? It's always perpendicular to each other anywhere you see that. Here also, if you see that normal and displacement are always perpendicular to each other, so normal work done never will come. Next, gravity work done. Gravity work done will only happen for A to C part. Gravity work done will only happen from A to C part, because after C what will happen? Gravity and displacement also becomes perpendicular. So gravity work done, if you want, you can, just for understanding, you can write it, work done by gravity from A to C. Next, friction work done. Again, A to C there is no friction, so no work done. But from C onward, the kinetic friction will start acting and it will start working. So C to B, I have to write the work done by kinetic friction. I've just write these value. What is the work done by gravity? Body is coming down, so plus, how much plus? Mass is m, g, and h. H is 5 plus. Understood? Work done by gravity, how much it will come? It will come plus. Next, work done by kinetic friction, negative. Why? Because when the body is sliding on the horizontal portion, that friction will be acting towards left. Body is sliding towards right. So that means kinetic friction will be doing negative work done. How much? Minus. How much is the friction force? It is going to be mu into normal. Kinetic friction, na? Normal is 50. So that is the friction force. And displacement. Let's call the displacement is something x. What is x here? Distance between C and B, which is they are asking us to find out. If I simplify it, am I getting 50 into 5, 250 divided by 0.4 into 50. That is the value of x coming to us. So what is the x coming? It's coming 250 divided by 50 into zero point 0.4. 20 will come. 5 into 4, yeah, 20 will come. So if you simplify it, it's coming 0, 0 getting cancelled out. 12.5 meter it is coming. So that means on the horizontal track, it will cover how much distance? 12.5 meter it will cover only. Understood? After covering 12.5 meter on the horizontal track, it will come to rest. Understand? Next example we have. In this example, what is given to us? Same track I am giving you, but this time this everywhere it is a smooth surface. Okay, everywhere it is a smooth surface. Same 5 kg block is there, and the height I am taking same again. The height is given as 5 meter, but here what is the difference came, that there is a spring connected here. The spring constant is given as 50 Newton per meter for the spring, ideal spring. Everywhere smooth surface is there. Okay, everywhere there is no friction in this question given to us. Now the question they are asking that find find maximum compression in the spring. Understood? Find maximum compression in the spring. Understood? Everywhere it is a smooth surface. Okay, everywhere it is a smooth surface. Now tell me what will happen when the block will come from this topmost point. it will gain some kinetic energy, na? But as it starts getting spring to compress, then what will happen? Its velocity will keep on reducing, and when finally the maximum compression will occur, can I say that at the time of maximum compression, the particle is just about to stop. So at the maximum compression, particle velocity is going to be how much? It's going to be zero. Understood? So please tell me, just apply this equation and tell me how much is that coming. Apply it and tell me how much is this coming. Work this maximum compression in the spring. Tell me. How much it is coming? What is the maximum compression coming? Tell. Can you tell me how much is this coming? See, again apply the work energy theorem in this question also. How much it will come then? See, at the time of maximum compression, what is going to be the velocity? So at the time of maximum compression, because the question asked at the time of maximum compression, okay, what will happen? The velocity of particle is again going to become zero. So let's say the spring got compressed by this much. How much it got compressed? Something x. Now, if you write the final kinetic energy, because it's a maximum compression I am calculating. So at the time of maximum compression, we got to know the velocity zero. Velocity zero means at the time of maximum compression, the kinetic energy is zero. Okay. So if I write work energy theorem here, the final kinetic energy zero, initial kinetic energy zero, work is done by normal, gravity, and spring. These are the three forces. Zero. What is the work done by normal? Again, you see that normal is always perpendicular to what? The displacement. The work done by normal will come zero plus gravity work done. Gravity work done will only come up to this portion, isn't it? Because till that portion, body is coming down, and after that portion, so body displacement and gravitational force become perpendicular to each other. So that moment onward, the gravity work done will become zero. So write it how much it will come. It will come plus mass is 5, g is 10, height is 10 plus work done by spring. Tell me, spring is getting compressed or getting elongated, or tell me what is happening with the spring? Is the spring is getting compressed from the natural position? Whenever spring get compressed from the natural position, work done by spring will be negative. How much negative? Half a and x squared, where x is the elongation or compression. Out of that, whatever happened in the spring got compressed by x, which I have to calculate it in the question. That is what I am taking as the x. Now simplify it. So we are getting x squared equal to What next we have it in the calculation? X square equal to 5 into 5, 25 into 10, 250 divided by 25 by 2, sorry, 50 by 2, 25. That is what we have. So what is the value of x we are getting? Root 10 maximum compression of how much? Root 10 meter we have. Okay, clear? Okay. In this next example, what is given to us? There is a vertical spring given to us in the question. Okay, massless spring, ideal spring is given to us. Spring constant is given as 50 Newton per meter given to us. And there is a kind of pan here. Okay, pan, or you can say platform is there, but this is a massless one. Okay, this is a massless. You can take it like a platform is there. And on this platform, what we are going to do, we are going to bring an object of mass 5 kg from the top. And initially the platform is what height? Initially the platform is 5 meter from the top. Initially the platform is where? Sorry, initially the platform is how much? Initially the platform is 5 meter from the object. And now we are going to release the object. Okay. Don't consider any kind of air resistance or anything in that one. Okay. Air drag or air friction. Okay. Ideal condition we are considering. Now they are asking what will happen when this block will fall on the platform. As per the question, it got stick to the platform. After falling, it may jumps back also, na? But in the question, what is given that after striking the platform, it sticks with it, and then both are getting compressing. Both are compressing the spring further. Okay. So again, the question asks, find what they will ask you. Find maximum compression. Find what? Maximum compression in the spring. That is what they are asking again in the question. Please tell me how much is that coming. Just take 2 minute time to apply. Again, the moment they will ask you maximum compression or these kind of thing, maximum compression, the body is about to come to rest. Please keep in mind that thing about the maximum compression or elongation thing. Okay. So please apply work energy theorem one more time here and tell me how much is that coming. So please tell me how much is that coming. Please try it now. Please try it and tell me how much is that coming. Please tell me, trying this one or not?
Yes, sir.
Yeah, apply the work energy theorem right now. Maximum compression situation, what will happen? Can I say at the time of maximum compression, this platform and the block will look like this, isn't it? And how much is that? That is something x we have, isn't it? Particle is released here, so initial velocity 0. Maximum compression, final velocity also 0. Let's apply the work energy theorem. Again, if I apply the work energy theorem, change in kinetic energy, here only two forces are there. One is the gravity, other one is the spring. Gravity will keep on acting throughout the journey, isn't it? Gravitational force will be acting on the block throughout the journey, but spring force, it will only start acting once the block comes in contact with the platform. After that, na block will start compressing the spring. So spring will start doing the work. If there is no compression, no elongation in the spring, what will be the work done by spring? Nothing. Let's write the value. Final initial 0. What is work done by gravity? Is it positive or negative? The positive will come. How much it will come? M Z into. Can you tell me what will be the value here? 5 plus x. That is the one mistake we make it. We forget to write this part, work done by gravity. Gravity is always working, na? From initial to final point, the gravity is always working. So work done by gravity will be how much? It will be plus mg into h, and height difference between initial and final point. It is 5 plus x plus work done by spring. Please tell me how much will be the work done by spring? Negative will come. Why negative will come? Because spring is getting compressed. How much is that? Half. What is the spring constant? K. Half K. And how much spring got compressed? Something x. So x square we have written. Now here we are not going to get the answer straightforward because it has formed a quadratic. So this has become 25. So okay, tell me what we are getting our answer. This is coming 0 equal to 5 into 10, 50, 50 into 5, right? 250 plus 5 into 10, 50x minus 25 x square. So it has formed a quadratic here. If you take common, 25 1, 25 into 2, and 25 into 10 it will become, isn't it? 25 common, if you take it, then 1, this is 2, and this is 10 we have. So we just need to simplify this quadratic and we will get the value of x. The correct solution, or you can say that positive solution of that x is going to be our answer. So what is the quadratic we got? It x square minus 2x minus 10 equal to 0. So if you calculate x, you are going to get it minus of b plus minus b square. So that is 4 minus 4ac. So 4 into 10, 40 it will become, divided by what? 2 into a. So we are getting 2 plus minus root 44. So we can write it 2 root 11 by 2. 2 get cancel out. 1 plus root 11. Another answer is 1 minus root 11. That is negative. Not possible. What is the correct answer? 1 plus root 11. That will be the correct answer. So that is the maximum compression in the spring we got it. Please tell me, clear this one? Next example, sometimes they will ask you what is the work done by air resistance or what is the work done by air drag. Like let's say a particle is there, initial velocity is 0 and it is dropped under the gravity. From what height it has been dropped? It has been dropped from a height of what? 10 meter. and the mass of the particle is something given as, let's take same value, 5 kg is given to us. Okay. Now the question gave that when this block is about to reach the ground, its velocity is 10 meter per second. Please tell me. You will say, no, 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 sir. 10 meter per second is not correct. Its velocity should be under root of 2 g and h, isn't it? Is it what you are thinking? Sir, the velocity here should be 10 root 2 meter per second. And that is what you were calculating earlier. Yes, its velocity should be 10 root 2. But its velocity will be 10 root 2 when when there is no drag, no air resistance, then the velocity. So actually what I did, I just checked it, that what is the velocity it will get without air resistance, and gave you some less velocity than that. Can you tell me why its velocity is something less than that? Because in this question, I am even going to consider the air resistance. Understood? That's why I gave you that data. Understood? So in the question, they are asking falling under the gravity. To find work done, work done by air resistance. If I ask you what is work done by air resistance, your answer will come negative. But sometimes they will ask you change the statement something like this: what is work done against air resistance? Then you should only consider the magnitude of that value. Okay, the find work done by air resistance. Sometimes they will use the word work done by air resistance. Sometimes they will use the word work done by air drag or resistive force. Like that, they will use the word. Okay, in the journey. Okay. So in this journey from initial to final point, you see earlier, initial, final, all these places, velocity was known to us. Now again, you see in this question also, we have known the velocity of what? Initial and final, isn't it? Can I treat it this as my initial point and this as my final point? Please tell me. Do I again know the initial and final point? What is the change in kinetic energy? Because I know the initial velocity. That means I know initial kinetic energy. We know the final velocity. That means we know the final kinetic energy also. So that means in this question, we again know what is going to be the change in kinetic energy. Understood? Now that change in kinetic energy, we have to relate it with the work done, isn't it? So please tell me what I will write it. K final minus K initial equal to work done by all. Can you tell me what is the work done by all? Gravity is there. And what else is doing the work here? Is the gravity and air resistance. These are the only only doing the work. Now let's put the values. Final kinetic energy, half, mass is 5 kg, final velocity is 10 square, minus initial kinetic energy, 0, work done by gravity. Can you tell me how much is the work done by gravity, positive or negative? So body is coming down. The work done by gravity, positive will come. So plus, how much plus? M, G and H, है ना? Plus work done by air resistance or work done by the drag force, which we have to calculate it in the question, right? So how much we are getting? 100 into 5, 500 by 2. So 250 we have equal to 500 plus work done by what? To calculate it in the question. So what is the work done by air resistance we are getting in the question? We are getting minus 250 joule we are getting. Please tell, understood? This is the work done by air resistance. Now we got it. So please tell me, understood this one? So sometime what will happen? You have to look at the situation and find out these things. Clear?
Yes, sir.
Please tell me. Clear? So just take one example and try it once. Okay. A spring gun is given to us. Okay. A spring gun is given to us. This spring gun has something like this. The spring constant, let's take it 100 Newton per meter given to us, and a block of mass 4 kg is pressed against it. Okay, and this is kept on a table. This thing is what? Kept on a table, and that table is what? Let's take it 10 meter above the ground. Understood? And the question says what? This spring gun is compressed by, let's say, 50 centimeter. Okay, this spring gun is what? Compressed by 50 centimeter, and then it is released. Spring gun is, matlab a block is there, na? You have pressed the block by how much? 50 centimeter, and then you are releasing. So what will happen? It will reach the natural length, and after reaching the natural length, it will just leave the spring, है ना? And after that, its motion is going to be under gravity. The spring gun is compressed by compressed by 50 centimeter and released. Okay, find the distance from the table from table it strikes the ground. Another thing they can ask you in the question, with what velocity it strikes the ground. Okay, now. So that is what they ask in the question. Understood? The first find out with what velocity it left the table. Okay, right? And then apply the what concept? The projectile motion concept. Okay, please tell me. Understood this one?
Yes, sir.
Right. So let's meet it tomorrow. Okay, and we'll continue it from here. Okay, right? Okay, Sharon, Lokesh,
Okay, sir.
good night. Take care.